Okay, so time's up here. Thank you to the 6 of you that tried this. So this person, basically, I believe this is yes, yes, no. Those are not all correct. Yes, no, yes. Those are not all correct. Yes, no, yes. Nonlinear, linear, linear. So the easiest way to look at this is look for the x and the y, okay? And if they're just an x and just a y, there's no exponent, okay? And they're not being multiplied together, and they're not in the denominator. It's okay to have a fraction as long as it's not in the denominator. These are in fact linear. These, if I graph these are going to be straight lines. And so I'm going to show you on Desmos what that looks like. So if you come back to the Google Meet tab, 3y equals 12 minus 1/2 x is this graph right here. This is a straight line. Okay. The other one, y equals 2x plus 5, this is actually in slope-intercept form. Y equals 2 is the slope times x plus 5 is the y-intercept. That is also a straight line. This is a form that you use when you want to graph something, because the 5 tells us where it crosses the y-axis, and 2 tells us how steep the line is and what direction the slope goes. This is a positive uphill slope. So for every 2 units up, you go over 1. For every 2 units up, you go over 1. And yeah, you can see from here, I could rise to 6 to 7 and then go over a unit and have a point. And that pattern continues up 2 over 1, up 2 over 1. So these ones are linear, but the last one, the first one, is not. This is not a linear function. This is something else. And the reason why it is not linear is because of the squared on the x. Okay, this is actually a parabola. This is what we're learning about. So if I show you that graph, that's the graph of the first one. It's a parabola. This is called a parabola. And it's what you get when you graph a quadratic expression. So Unit 5, we've been working with quadratic expressions and quadratic equations. This is an example of a quadratic equation, which is also a quadratic function. All right. And so we're going to look at graphing these things that we've been solving. Now, that's what's next. So this first one is not linear. It's actually quadratic. The second one is linear, and the third one is linear. So this is the beginning of Unit 6, and it's two sections of the book, 19.1 and 19.2. Graphing quadratic functions. Learning goals, I can identify the maxima and minima of a quadratic function. Maxima and minima, these are just fancy math words for maximum and minimum. I can determine the transformations of a quadratic function. So these are our learning goals for the next 2 days, today and tomorrow. And so when we talk about a quadratic function, we define it as a function that can be represented in the form of f of x equals ax squared plus bx plus c. The terms of a, b, and c are constants. So a, b, and c, these are just numbers. And a cannot be 0. So if a was 0, this term would disappear, and then we would just have something that's linear. Like here, these two, the red, the green and the blue lines, the x is just a single x. It's not being squared. But here, if I take away that squaredness, okay, well, the whole thing disappeared because I think I'm too far up. That's just another example. So anytime you just have a single x without an exponent, but if I add the exponent, it's going to turn into a parabola. All right, so these are quadratic functions that we're looking at. The greatest exponent of the variable x is 2, so it doesn't get larger than 2. It's either 1 or 2 on your x's, okay? But you do have to have an x squared term. You can have an x term or you cannot have an x term. It just depends. The most basic quadratic function is f of x equals x squared. This is called the parent quadratic function. And so this is a graph of f of x equals x squared. It's a parabola, okay? This point right here is called the vertex, and it's at 0, 0. If I look at it over here, okay, this is the same graph, f of x equals x squared. So you guys, we're going to be using the Desmos graphing calculator a lot again. So if you want to have it open, you can. Probably bookmark it somewhere so you can get to it quickly. And so there's more vocabulary that goes with these functions. The name of the graph is a parabola. So it's a graph that is a symmetrical curve. This blue line is a parabola. The vertex right here at the bottom is the point through which the parabola turns directions. So it's going down, 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 and then up, 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 up. So this is the point where it switches directions. And this vertex can be the minima or the maxima, the minimum or the maximum, depending on what you're looking at. Here, this is a minimum because it is the lowest point of this parabola. It's a minimum or minima. And then axis of symmetry is a vertical line that passes through the vertex. Okay, here's the vertex. Here's this orange dashed line passing through the vertex. It divides the parabola into two symmetrical halves, and it's vertical. So like if you were to imagine folding your parabola in half, where this is the line you fold on, it's like a mirror line. It's a mirror image across it. Okay, so there's a lot of information on this slide, but this is a graphic organizer to help you see how our parent function f of x equals x squared, how it changes. Okay, so how does the value of a in g of x equals a x squared affect the graph of f of x equals x squared? So we can tell things about this graph without always having to graph it and look, but sometimes it's helpful to do that so we can see that. So right now we just have f of x equals x squared. This is the parent one. Okay, I'm just if I change this a little bit, so a means I have a number in front of it. Right now there's a 1, right? It doesn't change at all if I put a 1 there because that's an invisible one that's already there. But if I change it to something maybe larger than 1, like 2, my graph gets narrower. If I change it again, 25, it gets really super narrow. 250, even more narrow. Okay, so when your a is a number greater than 0, well, your graph opens upward like the parent. Okay, that's the way that it's open. And 0 is the minimum value. Okay, so this is for all values of a greater than 0. These two things are true. The minimum value here is this lowest point of the parabola. But these two cases here, so we looked at a is not only greater than 0, but greater than 1. It's a vertical stretch. If we go and choose some value of a between 0 and 1, some fraction, proper fraction would represent a number between 0 and 1, then we're going to have a vertical compression. So let's see what that looks like. I change this to 1 divided by 2. It got a little bit compressed down or wider. And so I can then change my denominator to be even a smaller fraction, getting wider. So as your denominator increases, the value of the fraction decreases and gets closer and closer to 0, and your graph gets wider and wider and wider, more and more compressed. All right, it's a vertical compression or a vertical stretch depending on the value of a. Anytime a is positive, greater than 0, if it's a fraction between 0 and 1, we get compression. If it is greater than 1, it is a vertical stretch. So that's this path over here on the left. But now we're going to look at what happens when a is actually less than 0. Less than 0? Less than 0, that just means a negative number, okay? When that happens, these things are going to be true no matter what negative you have. The parent is reflected across the x-axis. It opens downward, and 0 is now the maximum value. So if I get rid of that, go back to 1x squared, which is the parent function. But now I'm going to make this negative. It just flipped across the x-axis. It's now opening downward, and the greatest value, the maxima is 0. So when this is negative, this happens. These things are true. And now you can be more specific about what your negative number is. So right now we have a equals -1. No stretch, no compression of the parent, same width. And that's exactly what we have here. And I can just show you again, there's x squared, there's negative x squared. It's just flipping it. It's not changing if it's compressed or stretched. Now, if a is even smaller than -1, like -10, it's getting narrower, or -100, it's getting narrower. And you can see that. It's a vertical stretch. Now, the last possibility is here. A is a number between 0 and -1. So it's a fraction, a proper fraction that's negative. Like -1/2. It got compressed. Or -1/20 got even more compressed. Or over 200, even more. Okay, so these are graphs of quadratic functions. This is the parent quadratic function, f of x, function of x, equals x squared. The number in front of your x squared term is 1. When you don't see it, if it's anything besides 1, well, this will tell you what's going to happen to it. Okay, if it's greater than 1, these things are true, and then these things are true based on what the value is. If it is negative, less than 0, then there'll be one of these 3 possibilities. So any number in front of your x squared, you can figure out what it would look like using this graphic organizer. Okay, so this is the example we're going to do together. Question 1, which equations represent a function whose graph opens downward? Okay, so we have all these different equations to look at. G of x equals 1/2 x squared. H of x equals -8x squared. J of x equals -x squared. K of x equals 7/500 x squared. Notice instead of f of x, we just have different letters here in front, and that's totally normal. That's how they just name functions in math, is they just use random letters to represent different functions. F of x is really common, but after that, you can use basically any letter you want, because you can see both for 1 and 2. We have P of x, Q of x, R of x, T of x. It's just different ways of representing it. Desmos should take it the same way. If I take that F out and put G, yeah, it recognizes G, recognizes H. Okay, it'll take any letter you want there. So we're going to figure this out using our graphic organizer. you can also use Desmos to check your work. Which equations represent a function whose graph opens downward? So I'm going to come back to the graphic organizer and look for what has to happen for my graph to open downward. So if you just look through here, it's bolded, opens downward. It's right here. And so that means that anytime A is a number smaller than 0, another way of saying this, A is negative, the graph will open downward. So we're going to look for where A is negative. And notice it says equations, okay, plural, so there could be more than one correct answer. There's that S at the end of equations. We want a function whose graph opens downward. So this means that A is negative. If I look at the first one, g of x, A is 1/2. 1/2 is not negative, so it is not g of x. H of x, A is -8. That's a negative number, so this graph will open downwards. And you could even come to Desmos and check that. Yeah, I'm getting all kinds of funky stuff because I erased too many things. Okay, f of x equals -8. It does open downward, okay? So B is one of our correct answers. I check the next one, j of x equals -x². Well, I don't see a number, I just see a negative sign, but there's always an invisible one, so -1. Yes, that opens downward because it's a negative A. And this last one here, k of x equals 75/100. This is a number smaller than 1, but it's not negative. So this one actually opens upwards. And you can check any of these by just going to Desmos as well. 0.75 still opens upwards. All right. Now, number 2, we're looking for something else. Now we're looking for which equations, plural, okay, so there could be more than one, represent a function whose minimum value is 0. Minimum value is 0, okay? Right here, this is an example where the minimum value is 0, because if I'm looking at the y-axis, the smallest value is here at 0, 0. It's a minimum. If this was flipped upside down, then 0, 0, this is the maximum value. So if I want the minimum value, I'm looking for a parabola that is flipped upside down. And that's what it says here too. So I'm sorry, scratch what I just said. If I'm looking for where 0 is the minimum value, it needs to open upwards. Sorry, this is not what we want, because this is a maximum. We want that to be a minimum, which means it has to open upwards, which means this has to be positive. Okay, and that's where it says it here in the graphic organizer. 0 is the minimum value. It opens upward. So A is greater than 0. We're looking for the number in front of the x² term, the coefficient, to be a number that is positive. Greater than 0 means a positive number. All right, so just start going through them. A, we have p of x equals 3x². A is equal to 3. It's positive. Awesome, that works. Going to the next one, q of x equals -6x². That's a negative A, -6. It's negative, so that's not going to work. That one's going to open downward and have a maximum value of 0. Our next function, r of x equals 1 and 5/10 x squared. This is a positive value of a. 1 and 5/10 is positive. So C does work. And the last one, dt of x is equal to 1/10 x squared. This is a positive number, so it works. So you can tell a lot about the graph looking at the coefficient of the x squared term, the a. It's called the a, and that's back here. So whatever it is, you can figure things out. Or just graph it in Desmos. You can see it too. Number 3, consider the function represented by d of x equals negative 2x squared. Describe the graph of d of x. So we can describe it. We could graph it in Desmos and look at it. Or we can just look at the value of a in front of the x squared, the negative 2 here, and that already tells me a lot about it. This number negative 2, if I go back to the graphic organizer, a is negative 2. So a is less than 0. And then I can even go further. A is negative 2. So it is actually less than negative 1. So it's a vertical stretch. It's reflected across the x-axis. It opens downward. The 0 is the maximum value. All these things are true. And we could write any of those things that we want. And we will. We're going to type them. When you're using the typing tool, like the default size of text is kind of large for this, so you can make it smaller just by dragging the, there's like a little slider you can drag. Then you don't want it too small because then you can't see anything. All right, opens. Downward. That's true. It's negative. What else do we want to write? Opens downward. It's a vertical stretch. You can write a lot of things here. Vertical stretch. If we look at it too, negative 2. You could say where the vertex is located. The vertex is, sure. There you go, Mauricio. The vertex is this point right here. It's at the origin. We could say that about it. Okay, there's lots of things you could write. Part B is 0 the maximum value or the minimum value? There's the picture. Here's 0. It doesn't get any bigger than that. That's the maximum value. 0 is the maximum. Okay, and we have one more question here. Number 4. Compare the graphs of f of x equals x squared and g of x equals negative x squared. How are they alike? How are they different? I'm just going to come to Desmos. There's f of x equals x squared. And f of x, oh, I'll use g of x equals negative x squared. Okay, so you can see both graphs at the same time. How are they alike? How are they different? They both have the same vertex. That's a similarity. They're both parabolas. That's a similarity. They're both neither stretched nor compressed. They're the same width. Okay. So you can say those types of things for how they're alike. How are they different? Well, they open different directions. So f of x opens upwards. Negative x squared g of x opens downwards. 0 is the minimum for f of x, whereas 0 is the maximum for g of x. Those are some things we could say about them. Those are some different things that you can write here. All right, so when you're ready, you have a check for understanding question. And so I'm going to leave my work up here for this slide. You want to copy that down. And then you would just do that last slide. And that's it for today.